So today we're still doing the same thing that we did in the past all streams. So I should change that and I should change my position. I'll I'll change the position of the green screen because I don't like that. Oh yeah. Okay. So let me just open some music and I'll change my microphone because I rewatched my stream. Hey, so I believe this is going to be better. Noise gate. What if I close noise gate? I believe this is going to be better if I just open some music here. So like that. Okay, okay. I think this is just fine. Because when I watched my stream again, I just couldn't hear myself. And one of the reason is I am a non-native speaker. So I can't I can understand my accent, my own accent sometimes. But one of the reason is just sound was just shitty. So I believe I will change my green screen's position. I'll tweak my camera webcam and I will definitely improve my audio. Right now I'm not sure if this is better or not. So let's watch. But I need to load my stream. So let's watch. Yeah, I think this is just better. I need to load my. Yeah, I think this is just better. So again, welcome everybody. We are continuing to develop the Etros project, which is how can I say that? Which is an automation tool, automation for the rest of us. It means, and the idea is that you will just create a JSON or a TypeScript file without anything complex. You'll just define what your command is in the system you want, and then you'll execute the function, like not function. You'll execute execute the shell commands. I can't talk sometimes, so forgive me for that, but I believe the project is good enough. Oh yeah, something happens every time I open this folder. The project is good enough to let me just forgive myself for the crime of not talking properly in proper English. And steps folder. So right now we got a memory leak. So Rustaceans are laughing at us right now. What? Sometimes we got leak and sometimes we don't. Why? Why? Before opening the stream, I just run the same command. And it just crashed. Right now, why you're not crashing, man? Let's see. SD caches, Etros, Vim, test cache. So what if I remove that? I don't know what is going on. After streaming, it just magically disappeared. I'm not sure why. So what is going on here? What is going on here? let's see. So okay, this one gives some error here. Arena alloc. Yeah. Oh yeah, it just crashed again. So what is the problem here? Okay. So if we got the cache, let's see if counter, okay, wait, we need to remove those. One thing I don't like about Zig is that actually, so I'm starting to getting the problem. If you don't have the cache and it runs properly without anything, it doesn't crash, but otherwise this happens. So let's take a look at the problem. I think this just looks better. Okay. I'm getting the issue, I guess. Caches items length. So maybe we are not deallocating the caches. Maybe. Step executor, cache executor. So cache.dnet runs, but in the cache.dnet we dnet the let's see, const arena alloc, or just arena is going to be std heap arena allocator, and just init allocator. Okay, and defer arena dnet. Yes, that's correct. My pinky just hurts. I think there are some problems I need to fix in this current setup. Am I not energetic enough for a stream? I'm not sure. We'll see that, but I need to change this to mutable or where I'm not sure how to pronounce that, but I know mutable. So const arena alloc, arena allocator, JS bundler, arena alloc. Okay, let's try that one. Oh yeah, I think I got the problem. I know where the problem is right now, but I don't know how to fix it yet. So let's see. Yeah, this is the problem. This is the problem. Okay. No, not arena, just allocator, please. Let's see. Yes. We can't dnet. Actually, let's continue with that. So we can't dnet. What we can't dnet here? So what is the problem? Where do we use allocator? So cache folder, get cache directory. Inside that, OS cache path. We are deallocating it. So I guess this is not the problem. And let's see. Allocator. So the next step is file. What file to caches? Yeah, allocator. You're getting the allocator here. Let me change. Okay. So file to caches. I think the problem occurs here. So cache list. We need the cache list. But we return the cache list at the end. Oh yeah, so it might be about this one. Okay, I think this is about we are not deallocating the line, but we'll try that out because we are deallocating the cache list and there's nothing else here. So title, let's take a look at that. Title and true, yes. Reader, yep. Let's see. Yeah, this gives us no problem. I should copy that and let's see if yeah, okay. Okay. The problem is that we are not deallocating the line. Read until delimiter. So is there any way we can do without? I think there is. Read until delimiter or end of file. So what does this guy take? Stream too long. Set that size. So yeah, okay. Let's see. We will need so we will need to just define a buffer with a length. So a title's length is going to be a maximum of 100 letters or characters. Characters is better. So undefined now. Yeah. Stat. Where's stat? Return cache list. Okay. Yeah, this just fixed that. And if we were to do something else, we could do like mem copy. And actually, since we are just trying out, I think I'm gonna try that too, like that. And success. So let's see. Let's take a look at what people solves. Mem copy. Actually mem copy. Just mem copy. Oh, Carl Seguin. I read a lot of Carl Seguin blogs for Zig. Actually, I suggest you to do the same thing because he just knows his stuff. He knows Zig well. I think Dark Team to be better for most of us here. And I should be more energetic, but I got some problems, I guess. I'm thinking a lot in streaming, not in a dramatic way. I'm just thinking like, what should I eat right now? I've used if you used Zeek for a bit, you'll probably come across the memcopy built-in. It copies byte from one region of memory to another. For example, if you wanted to concat two arrays, we could write a little helper. Concat, okay. Concat, but actually concat is something we already have in the standard library. std-mem concat. I think they implement this same way. Memcopy, yes. Okay. Okay. But I should try two steps if I'm going to use buffer, by the way. So okay, you might have also come across std-mem copy forwards, copy backwards. Okay. So I could end of defer allocator free line, which is a slice of U8. Okay, that's fine. So what we should do at the end is title. Where do we use line? Split it. Okay, using this makes no sense right now, but I think it would be great if like if we have an array list of slices of U8s like that. When we destroy the array list, I would expect it to destroy every single item. Like this is a slice, so but you can't know if it is going to be better or not. So actually, you know what, we could use this same stuff. Wait, where is the init? So I could do something like for self that caches items. An item is a cache item. No, not cache item. Let's mark this place. We'll need that. yeah. No matter what, we just we can't reach. Yeah, we can't reach the real slice. So yeah, we can't use that here. Okay. Free line. Yeah, we can't free that too. What we can do? Right now I'm not thinking how should I write the code, because the best way is just that. But I'm thinking about memory allocations. I haven't allocated my own memory before. Like, I've either used Rust or Go or Go or TypeScript. Like, I've either used a garbage collected language or a language that takes care of the memory with types. So this is a new concept for me, which is actually pretty enjoyable. But you have to think the way before you implement it if you are new to a concept. So I'm thinking about that. So what we could do here? So we could create another array list which just adds file to caches. Maybe every cache should hold the line. Cache item, let's see. Title, success, and maybe we could give it a property called line, which just keeps the keeps the line pointer itself. Like we could do something like line constant weight. You got it? So yeah, this would be the solution if we didn't know the maximum size, and actually we don't know it. But the problem with here in Zig, we can't define private fields. I wish we could have, because like in Zig you need a lot of unnecessary to developer fields. Like some fields are only there to keep the pointer, because you need to deallocate the pointed memory. And it is actually more needed in Zig than in Rust, but Rust has it. Zig private fields. Struct fields are always public by design. And I am not against that, because always using pub keyword is not good, especially for databases. You need to create structs, especially in SQLX in Rust, and I don't like using pub like everywhere, like it's just crazy. Private, but public by default, but can be private. This is the best way, in my opinion. So I think this is just closed or not. Wait. Yeah, I don't think it makes things much simpler in this case. For example, we need to keep the what pointer, but if we do that, we got a new line, and um, I didn't like this approach at all. The color owns the memory. If you create an array list, it owns the memory for its items. But you, the instant shader color, own the memory for array list. Nobody can really stop you from messing with memory that you own. And on the other hand, in Zig, you'll have a genuine interest in messing around with memory when needed. One example would be restoring the previous state of a random generator for whatever reason. Another would be maybe allocating two structs, one next to the other in the same contiguous allocation for whatever reason, and then serializing them and then deserializing them afterwards. One could have every library lock down all fields and provide function for gated, protected, safer solution for each use case. But in my opinion, the variety of weird thing that the caller might have a legitimate need to do is not something that a library author can fully anticipate. Which means that more often than not, the solution offered by the library would not do the optimal thing given the use case. Parser. AST. What is an AST? Okay. So this is a vision stuff, I guess. Okay. Okay, oh wait. So this is some spicy stuff. Jared Sumner. Okay. Oh wait, I gotta take this message. Okay. Yeah, at the end of the day we got some spicy stuff, but like I said, I think it would make the language better in like in a lot of cases, because for example there is no interface syntactic sugar, so you need to define the function for interface, so function for interface 2, 3, and these are all are a function, a pointer to a function, so const function. You got it? You got my point. So and then you create interface, actually function interface, which returns the interface. So everything else here is inside a vtable if you like this approach. So this is an object, and some people likes that more, like me. And so you got that, but still you got a vtable like visible to the developer, and a Zig user knows a vtable is required for an interface, but a new user would like to look at that. And also, if you don't use a vtable, it just means that there are a lot of functions, and the interface also returns the same functions with the same names. And we see that in structs that implements writer and reader. Like we got the reader functions and writer functions outside of the interface, the reader and writer interface, and we can say something like that, my struct that reads, and also we can say something like writer, or actually reader that reads. So what this does is just it implements different ways that does the same thing, and I'm against that. I'm against that a lot. I don't like this. I think there should be only one way to do anything, if possible, of course. And this just prevents that, in my opinion. Again, a vision or an opinion can change after you learn the language in depth. And right now, this is what is happening. A year ago, I would say Zig is not that, not that needed. But after I found out what Zig does, what Zig enables us to do, it is hard to go back and say Zig is not. It creates something new. It creates a whole new strategy for allocations. You can allocate your stuff with safety. I'm currently not that safe, but it is going to be. I'm just hoping for that. There's an ongoing GitHub commentary. I'm not sure what GitHub says its name is. GitHub Zig safety Andrew Kelly. Yeah. Zig roadmap. Zig pointer to Zig safety. Oh yeah, is that it? No, this is not the one, I guess. but there are some safety stuff going on that now you can do something like function my function which returns, let's see, so this returns a const u8 slice of const u8, and you created the I don't know or just one element. Let's see, like that, and it is, I don't know, this is not true. So hey, if you return that, this is an undefined behavior in Rust, but here it lets you do that, and you feel like there's no problem with that, but there is. Actually, I'm not sure about this case because we defined like this is a compile time known stuff, so this can be created inside the compiled program itself, but I don't think so because we didn't create it here. So this is a static memory right now, and I should try that out, but trying that one out is problematic because if you just run my function in main, so running that this is going to run and it will going to give no error because you just run this function and then exit it, and it freed this. Actually you can do something like let's see, returned, so this is a string, right, and you can print returned. This is going to give any error because you haven't allocated anything to stack after running this function. So stack is free, not stack is freed in a way that the computer, the compiler, or I'm not sure what, I think it is a compiled language, so yeah, the architecture, the CPU is going to say that this memory is freed and no one is going to use, because CPU doesn't look at that. This is a job of compiler, and it is going to remove that memory if needed or replace that memory. So this is an undefined behavior at the end, but Zig doesn't care for now. As I said, there's an ongoing conversation about that. Missing struct line. Yeah. Okay. Let's remove that and let's get back to work. Yeah. Let's see. I couldn't find my terminal. So yeah, this is the way. But let's try that with other title and true. So let's see. Let's just copy everything. Example 2. I hope this is going to work too. What was that? Other. This is the other one. Give me just a second. I just changed where the chat is so I can see if anyone messages. Okay. echo hey, this is the other one, and I'm going to remove the cache to see what is going to happen. And actually I'm not going to try that one out yet, just yet. And allocator, so for that reason, where is it? Cache executor. Okay, arena alloc. Let's see what is going to happen now. Yeah, the 2 steps runs in the reverse order, but I don't care about that for now because we don't have any stuff for ordering them. And now let's see. I'm going to remove this, remove arena allocator, cache init. So let's take a look at this one. And after anything, I'm going to print caches in execute. In new line, I'm going to write caches. And again, new line. Let's see. Oh yeah, reverse new line. Okay. Let's take a look at. Is there a leak? What is going on? Wait. No, there shouldn't be any leak. Okay. Let's do something like caches. Oh, this is a list, so items. What? Wait, what? Why I can't write title? Split it next. Yes, this is true. Oh, no, not any. Oh shit. Oh shit. That's what I'm talking about. Yeah. Okay. So no matter what, we will need to keep that pointer. So did you get it? There's a free after use. Use after free. We define some stuff with. So, okay. I'm really getting tired.
Master of the sun, memories falling on concrete. Leaving no behind. Now you swear to be my enemy.
I wanna try using the mem copy. I guess I'm just gonna keep the line. Yeah, okay. But I didn't like this approach at all. Maybe mem copy is going to be better. Who knows that? Do that. Cache line. Okay. Oh, we don't keep the allocator. Or instead, we could create an arena allocator. Right? Yeah, this is right. Oh, actually, I wanna try that one out. Yeah, I really like this. I just wanna try that. Arena. STD man. STD heap arena. Allocator. Not const. Yeah, const. Okay. Oh wait. We will return the arena allocator. But wait, I actually like. Oh wait. I only want to change. Where was that? Cache. Yeah, okay. I didn't like this approach too. Okay. But we can't know without trying, right? Oh, wait. Let's see. What is the type? Okay. Yeah, that's correct. File to caches, reader, buffer. So yes, this just fixes the problem, but I am not sure if this is the best way. This is the one that I could find like the best. And again, this is not required in anywhere else. This is just for the init function, which is inside the struct. So I would love to. Oh, yeah, headphones running out of battery. But anyways, I'm not energetic. I should be energetic. Okay, what is next round now? I'm thinking about mixing a controlled allocator and just dumping memory allocator, which is an arena allocator. I'm not sure if this is the greatest way. For example, if we could just use and dump memory like from the beginning, then why we didn't? Like we could do executor. So we could just define this, and then we could use this for JS bundler and cache at the same time. But okay. And also JS bundler doesn't return something that's allocated inside the allocator given. So if it is better to define the allocator inside or give it to the function. So I'm just going to ask that actually. I just wondered that. Let's open my okay. But currently we have cache. I'm gonna remove everything here and here and here. Then go to execute steps. Open. Then right. Okay. User input is error defer. Why error defer? Oh, okay. If a number please, what the fuck? You ran this test successfully before. I'm not sure what character is inside here. Just a second. So no character. If let's see, user input that len is 0 or std mem equal. I start to not liking writing this every time because it makes it makes the if statement longer. Like this is a known stuff. Input. Oh wait, this is yeah. This breaks the while loop, right? I'm going to define a scope name while Go. Yeah. Else if stdmem equal u8. Yeah. Why? Wait. It will start with user input. Zik capitalized string. Oh. Let's see. To output. Oh man. Wait. What is that? So, why do you need that here? Yeah, because it's the slice, okay. Else if std mem equal u8. What? Answer and why? this is going to not equal. Oh yeah, if we can do that. So is there any not keyword here? No. I just thought about it because we have and or keywords. Let's see. STD error. No. Log. Actually, I just wanna panic. Where is it? No. Process exit. Let's see. Unexpected. Okay. Let's see actually. You know what? Actually, we can do something like. Let's see. Else if let's take a look at that. Oh, so we don't need else if right now. Oh. If it is yes, we'll need to print running the task again. Okay, I think this is the best way for the end user. Let's see what is wrong. Cache items 0 title. What the hell? Executed. Yeah, okay. So this was the first time? What the? What? Lower user input. Oh yeah. Oh, I've seen you in Louis Pilfold stream. So what I can do about it? You know what? I can ban you. What about that now? But thanks for following. So you ran the task successfully before. Ah, why? I deleted it. Segmentation fault. Oh shit. Oh shit. I will need to find another way to format and cache this. So just a second now. So we have a segmentation fault. Why is that? Okay. Rerunning that. Also, okay. This is new. This is new. What happens then? Okay, what about this? What? Oh yeah. Oh, okay. Something is going on inside this buff. What if I remove everything else and only no? Okay, this still sucks. Oh boy. Answer. What? We still get that? Mm. STD odd what? Oh no, no, please, please. Why? No, this is not about this one too. What the hell? So the problem was STD odd. Is that correct? Wait. I can't believe this. Yeah, the problem was STD art. Man, this feels terrible. This feels terrible. But at the same time, it feels great to finish another segmentation fault. Oh man, this language needs some love. Segmentation faults and memory leaks are really the worst issues you can encounter. And I am counting memory issue, I'm counting the stack heap. How can I say that? I'm counting the functions that returns a pointer to a stuff that created inside the function. I'm counting that as a memory leak too. Why these three or these two are the worst, you may ask? Because there is nothing that the compiler gives you so you can fix the problem. For example, especially I'm gonna give Rust as an example. Rust language has a great compiler. Not because it compiles fast, which it doesn't. Not because it compiles to a program that is fast. No, that can happen in any kind of compiler if the compiler knows the program. But because the compiler understands what you are trying to do first, gives you how you can do that, and you are doing it wrong right now, and it gives you ways, different ways you could accomplish this. For example, if you try to do that in Rust, this is going to say you are using 3 dots. This is not syntax. This is a syntax error in Rust, and it'll suggest you to use just 2. So this is great because the program knows what you tried to do. And also when you let's say function AO which returns a string, maybe, yeah, and you create the string, or you don't need to create the string, or let's just do that. Let's my str, so you can't just return that. This is not a value, this is a pointer. So Rust guys says that it is a value that doesn't hold the value, but it is shitty. It is just a pointer, you can say that. You can use terms that are invented before. You don't need to use smart pointers. You could say the pointers that looks at how, if you did like a box, you don't need to say box, you can say heap, right? Okay, because this is invented before. Otherwise you need to say box is it just creates the memory inside on heap. And then why this is a box? You just say heap. Like, you know, that's my point of view. This is the reason I like Zeek, because there are only constant U8 slices or constant U8 arrays. You can create them inside an array list, which creates them in heap. You can say why you are using array list, just use heap. No, you can't do that in this is not like logical in Zeek, because you already have std heap and allocators, like allocation strategies, to be actually like array allocator. So heap is that in Zeek. Not array list is an abstraction in top of the allocation. It creates the list and it checks every time you init something like or append something in the list. It just checks if we have enough memory inside the heap. Like it has, because strings has capacities. Just like that. I like this language because of its great choices and the greatness of the, its building blocks. I can't talk sometimes. But this is just the way it is. I like this. Oh. This is going to be the longest stream I have ever made. I'm going to make this 2 hours. Because why not? Right? I'm trying to try different things. And let's see. Okay. I think it is still too early in many. Oh, wait. I did something wrong. Oh yeah, okay. I think it is still too early in United States, in Europe, in some countries. But anyways, I'm just gonna take a break. I'm coming in 5 minutes, so let's just create a clock for that. Okay. Let's pause a second. Okay, I'm going. I'm gonna come back. I'm come back. Bye bye. Oh shit. I'm talking for nothing. Oh, this really made me sad. But okay, okay. I can live with that. I was saying, now what we need to do is we'll need to fix the caching. Like it can't happen at the end because we are breaking. Let's see. So where do we get? Oh, actually, this is not right. So task succeeded. So this runs why don't you do just like that, so this looks better in stream. What is happening here is if this is successful, what is the problem? Okay. This is not a problem yet. Answer. If it succeeded, this is going to happen. Should it be true by default or false? Let's think about it. We'll see that. So if it is successful, it'll just break. So I think we should say true by default. And then if we run that and if the exit code is not expected, like if the error code is not 0, which is success, we will change. What was that? Let's see. Task succeeded to false. Yeah. If we exit I think we shouldn't exit. So what happens now? Defer is going to be a scope, and then we'll just use them here. We can't try anything in defer. What we are going to do is const formatted cache. Format cache is going to be, let's see, where is the step? So yeah, okay. Wait a second. Wait. We need to do that here. Actually, here is better. Whenever we get a step, defer. So this is not going to be null. We'll change that. And therefore this is not a problem. So what am I going to do is just gonna copy that, const format cache format std array list. So this array list is going to be what? A U8? Yes. Okay. Then we can defer. Can we use defer inside a defer? Let's see. Within it. Oh yeah, we can. I like that. I really like that. So cache format that append slice, and slice is going to be step value that title, then again append slice, which is going to be this, their union. Okay. Can we return error here? Yeah, okay. Catch panic. Couldn't append to cache format in let's see in what. No, there is no need for that. Okay. Oh, let's see. Cache. I want to change Success. I want to change this to 0 or 1. STD man equal, success will be 1. Yeah, and then we can do something like let's see. But we'll need to change it to let's see. Okay. Oh wait. We're not using contouring anywhere. Oh no. It is because it is not mutated. Okay. I start to not liking the length of the file. Caching. Let's see. Catching and caching, okay. Yes. So let's see. Okay. Oh yeah, we really finished. We really finished the caching stuff. So now what we need to do is we will need to write the step title before this. Okay. I think we are in a great position right now. And I would love to just change the structure here. We can defer that. So, okay. We'll get this to where? To here. And we'll write the output if we need to. This means after this function. Okay. Let's see that. Oh yeah. Description. So if you got this error, it'll start with a new line. Let's try that one. Yeah. You ran this test successfully before. Skipping. No, we shouldn't show this. skipping the task. Oh yeah. I think this is the one. I'm feeling it. So we say no. Skip the task. Skip the task, okay. What about yes? Running the task, output. Okay. Yes, that's great. What about something that is an undefined behavior? Segmentation fault. df. df? So we got an error here. If you write something problematic, it doesn't give an error. Okay. What about that? Execute run. Oh, why? Process exit doesn't work. Why? No. Let's see. Unexpected key. So this one doesn't work. Equal to no, yes. Okay, I got no idea and I'm getting really tired. So I guess I'll end the stream because I also need to work in my real job. And thank you guys so much for joining with me, for listening to me, and I would love to see